I cannot be more grateful to you for tuning in, subscribing, and especially for commenting and leaving questions that you'd like me to answer as we reach this historic milestone in our journey to reach 1,000,000 minds. We're over 1/6 of the way there. Hello and welcome to a very special episode of the Into the Impossible podcast. 'Tis I, your formerly fearful host, Dr. Brian Keating. Today, we're recording a very special episode. This is our 150,000 subscriber celebration, subscriberation. Today, we're going to take questions from Twitter, Instagram, and YouTube, of course, where you're watching this. And the podcast audience can reach me at briankeating.com/podcast to also leave voice messages. We had a couple of those. We'll get to those and we'll get into it on our way up the ladder of success together, where you are enabling this magnificent, fun, mischievous mission that we have embarked upon for the past 3 years. It's hard to believe it's been 3 years. It's taken a lot of time. Maybe we're hitting a hockey stick type inflection point, maybe not. Time will tell. Maybe we'll see. But since the time that I requested comments and questions on August 17th to today, which is September 17th, we received an additional 12,000 subscribers. So it's pretty cool to see that rate of growth. And if it keeps up, T-Series, Mr. Beast, like Nastia, watch out. I've got you on my sights. So thanks again. Let's get into it all together. The 150,000 subscribers celebration. Here we go. First questions I will take will come from Twitter. So Twitter is now known as X, and it wasn't the last time I did one of these specials back in, it was only a couple months ago. We hit our 100,000th subscriber, and it's just so gratifying to see that. So first couple of questions will come from Twitter, and I invite you to follow me there and ask away, Dr. Brian Keating, on Twitter and Instagram, where other people are leaving comments as well. First question comes from a longtime friend of the show, Dr. Leonard Momini. I hope I'm pronouncing your name right, Leonard. He asked me, what has been my favorite scientific paper? I guess this could be interpreted as paper I've read or paper I've written. I suppose in the latter category, paper I've written, my first paper came out in 1997. It was written over about 2 years, from 1995 to 1996. I was a graduate student, started off, I was at Brown University, and I ended up writing a lot of the paper in the UK, in London, with my great mentor, Dr. Alex Polnarev, who I had the honor of inviting to my Royal Institution talk. And you should be able to see the Royal Institution discourse I got to do back on June 29th. That should be out by the time this video comes out. If not, subscribe to their channel and you'll see it. I'm very, very proud of that talk and having him in the audience, and you'll see a picture of him. So that paper was called The Feasibility of Detecting the Large Angular Scale Polarization of the Cosmic Microwave Background Radiation. So, doesn't exactly fit into a tweet or a post. Nevertheless, it was kind of prescient in many ways, mainly thanks to Alex and my co-authors, including my PhD advisor, Peter Timby. I'm still very close with at University of Wisconsin-Madison. And this was laying out what it would take to detect the polarization of the CMB for the first time back in the late 90s. Well, it wasn't detected until the early 2000s, when the DAISY experiment ended up making the first detection. But the actual focus of that particular paper was on detecting gravitational waves in the CMB. And of course, we thought we did that in 2014, a mere 18 years later. And of course, that was later retracted. But all of that stemmed from this very first paper that I ever wrote, the laying out what it would take to detect the polarization of the CMB. And later, the detection of the gravitational waves only became really the major pursuit of my career, and has maintained that, although branching out into many other fields, including radio astronomy and infrared astronomy. But still, that is the main focus of the Simons Observatory, which is going to be the legacy project that I am so blessed to be a part of and to co-lead with my friends and collaborators. So thank you, Leonard. That's really great. Amanda Johnstone, who I believe I met on Clubhouse. If you remember Clubhouse, RIP, Amanda used to host these amazing intellectual kind of salons where intellectuals would gather, and sometimes she'd bring me up to talk about cosmology and astronomy. And she asked me, what was the moment you realized you think differently to most? I think I've always been a little bit of an iconoclastic, driven person. I wouldn't say I rise to that level yet, maybe ever, but the point, I've always wanted to do something important. I've always wanted to eschew the kind of mainstream and cheap or fast thrills in lieu of more enduring pursuits, such as the life of the mind or deep relationships with family and children. And I believe that, the kind of focus I had, I never did any alcohol, drugs, anything like that in high school. Still have never done a drug, an illegal drug. And I hope I can maintain that, for the rest of my life. And that was always very different. People were getting drunk in high school and college, doing drugs. I never wanted to do that. I always felt like the brain was so precious. And I didn't want to monkey around with the circuitry. I was only allotted a mere handful of IQ points, and I didn't want to take those for granted. And I still feel that way, and I advise my children that too. A lot of parents have done. I'm not judging. A lot of my friends did it, and I was always the designated driver in high school while they, I chauffeured them around on dates. Pretty miserable experience for a part of high school. But I still am very close with a lot of my high school friends that are probably watching this video, and you know who you are. They're part of my council of elders that I rely on for wisdom and advice. So I think I always wanted to live a deep life and do meaningful things. I had a job since I was 12 years old. I wanted to be independent, have money, and acquire skills and resources to be the best intellect I could be, knowing that, going into academia wasn't necessarily a path to riches, but it was a path to doing something in the footsteps of my great heroes of that time, Isaac Asimov and Carl Sagan, and many others who influenced me to be a scholar or an astronomer, professor eventually, although I never thought I could be one, because the odds are so low that anybody gets into the professorate as it is almost a miracle, and I never take it for granted. So I think for me, it was always instilled in me by my parents to pursue deep things, not shallow things. For me, that was understanding the origin of the universe, which led me to question the biggest topics in philosophy and theology, religion, and certainly in fundamental physics and cosmology, which has been my passion and my vocation ever since. Okay, get on Twitter, Dr. Brian Keating. Omar Ghaffar writes, why were you so dismissive of the UAP issue on Joe Rogan? Do you not think it's wise for scientists to step aside and let the lawyers, politicians, and other investigators do their job here and figure out what's going on so that scientists can get actual data? I see a problem with scientists opining on this prematurely and negatively, and it's a constant theme that causes problems with these issues, particularly in light of where we are right now. Omar, I'm sympathetic to always being, let me phrase it this way, to not being dismissive. I don't think I was dismissive. I think I'm reflecting my actual perspective based on evidence, based on data that I've seen. And none of the evidence rises to the level of constituting proof for me and for many, many of my friends. You have to realize, even though I do come across, because I am pessimistic about the notion of not only extraterrestrial life, but extraterrestrial intelligent life that's visiting the Earth, I'm extremely skeptical about that. I still believe by any measure, there's a huge probability that I could be wrong. And I think that's important to acknowledge. On the other hand, I think leaving it to lawyers, no offense if you're a lawyer or a politician, Omar, but leaving it to lawyers and politicians is kind of maybe some of the worst cohorts to leave it to. I would prefer if you said leave it to the military eyewitnesses and so forth, but you didn't. So I'm just addressing what you said. And I don't think it's a purview at all of politicians. I think politicians have obfuscated many, many things. And if there were indeed alien technology and intelligences visiting the United States, for example, they would be the first to use it to their own particular purposes, where politicians' desire is to acquire power and resources from the people that they're supposed to be serving, but oftentimes they act as if they're monarchic, authoritarians, and I think that's very dangerous. So I see no need, and I think if a scientist can't opine, let alone collect the data on aspects of astrophysics, propulsion, engineering, time travel, uh, dimensional, modification, and so forth. Who is going to do that exactly? A lawyer? Joe Biden? Now, be that as it may, I've also been influenced by people such as David Spergel and others, and the people I've interviewed on the Into the Impossible podcast, including the pilots. And I've spoken to many of the people that claim that they've eyewitnessed things. So it's coming from a position not of dismissiveness at all. In fact, I've said many times I'd be the most, joyous, ecstatic person among that cohort to know that we're not alone. I just don't believe that the evidence we have currently rises to a scintilla of proof that we are being visited by UFOs from advanced extraterrestrial technology. And I've spoken about that a lot. So, no, I think we need more data. I've had on the foremost private, individual, and that's Avi Loeb. I've had on David Spergel, who led the NASA report. I hope to have Shelley Wright, who is one of the contributors to the NASA report. These are people that are advocating for more and more data from different media platforms, or shall I say sensor platforms, from space, from the ground, from the military, from civilians. And Avi Loeb, of course, the Galileo project, which I used to advise and just didn't have the time, and did feel like it was a little bit of a conflict of interest, because I do remain skeptical about the base layer of reality, which would require a alien life to exist in the universe. So I'm skeptical about that, let alone the technology that could be proffered by them. Nico Grunenberg says he was not suspicious, as dismissive as much as I thought he was, but rather neutral in making arguments why we shouldn't fall victim to authority bias. Yeah, that's exactly right, Nico. Dr. Keating made an argument I hadn't considered regarding the story of how in World War II the Allies could spoof radar. So yes, I did do, that was kind of spur of the moment, but it did come to me, this anecdote about Louis Alvarez, Nobel Prize winning scientist depicted in the movie Oppenheimer, who's at Berkeley, co-discoverer with his son of one of the leading theories of how the dinosaurs were extincted. It's called the KT boundary, and various types of deposits in the Earth's crust that indicate this was a meteor impact. And he did provide a tool that was used to spoof the German radar sets by basically tricking the Axis powers, the Germans, into thinking that Allied bombers were moving away from them when in fact they were moving closer, so that their sensors would have indicated complete violation of the laws of physics, that they were evading the inverse square law, and instead getting closer, even though their signals were getting weaker. So how could that possibly be reconciled? Well, it was beyond the understanding of the laws of physics how something could do that. And in fact, you would have ascribed perhaps superluminal motion to these objects, because if you think that something's 200 miles away and it's actually 2 miles away, and your sensor indicates that in a fraction of a millisecond, then these objects would be apparently moving much faster than the speed of light. So that's just one example of how we hear this. And of course, my friend Eric Weinstein has mentioned this many, many times, that if we believe these things are moving and violating the laws of physics, then we should have more physicists involved in this, not fewer. And I think I certainly do agree with Eric's sentiment. Back to Twitter questions. Artisan Tony says, will we survive the woo? I don't know, Tony. I'll say yes. I'll say yes. We will survive the woo. Okay. $Papa.Mas asked the question. Assuming Eric Weinstein's geometric unity model is correct, and distances in space and time are fungible, why don't you believe extraterrestrials have been to Earth? Well, quite frankly, we don't have evidence that Eric's model is correct, or any model that could allow for interdimensional travel. I've had Juan Maldacena on, We talked about anti-de Sitter space, and that could be another way to instantiate wormholes that could be traversable even by human beings, meaning that they would have a diameter greater than a meter. And yet we don't live in anti-de Sitter space. We live in de Sitter space. So none of these models for a unification of gravity or of forces have been established with any degree of credulity, including Eric's. Doesn't mean that they're not plausible. They don't have things that are interesting to study, and I keep trying to pursue these with a gusto to try to provide an experimental data that could validate or invalidate them. I mean, don't forget, a job of an experimentalist is not to prove a theory. It's to invalidate every other theory. And that's what we hopefully are doing with our projects, including things like the Simons Array and Simons Observatory. And we're imminently about to get first light data from the Simons Observatory. And we have incredible data already from the Simons Array. And these are really, as I stressed in my answer to Amanda's question earlier, these are predicated on my desire to only want to study the deepest, most foundational questions in what's called fundamental or elementary physics. That includes particles, forces, fields, and the evolution of the early universe. Okay, Dr. Tamara Soma asks, how does your spiritual views, I believe you have one based on your website, I don't know on my website necessarily, but how do they influence your approach to being a scientist and to doing science? Thanks, Dr. Keating. Thank you, Tamara. Well, I am religious. I do practice religion. Spirituality is kind of a woo word that maybe Artisan Tony was referring to. A spirituality is kind of a very strange term for me to identify with it. I don't mean to say it in a negative sense if you yourself are spiritual. I just mean that I am driven by I would say I'm a behaviorist, that I believe that your behavior influences your mind, your mentality, your psychology. Your brain can control your body and vice versa. So I believe in searching for evidence. And of course, if we had evidence for God, you wouldn't have the notion for faith. Everybody would just believe in God and say it was just belief. Like, I don't say I believe in gravity. I have evidence for gravity. So it influences the pursuit. And I just gave a talk. It was just my birthday. I did my bar mitzvah in Israel at the Kotel, at the Western Wall. That was a highlight experience for me. I think that deserves some sound effects. So if your ears are sensitive to sound effects, too bad. Here we go. We're going to do party noises. There we go. There's a blowing horn, trumpet bell. Oh, that was a drum roll. And last but not least, my favorite, that always makes me laugh, the DJ air horn for the bar mitzvah. And I did it at the Western Wall, and there's, of course, a great yeshiva there called Eish HaTorah, which in Hebrew means the fire of Torah, the fire of the Old Testament. And it was very awe-inspiring to me to be there. I wouldn't say I had a spiritual experience being there. It's the remnants of the Second Temple, which was destroyed in 2,000 years ago. A lot of people do. They put little notes in the wall, and no, that's not the Western Wall behind me over here in my mountain hideaway where I like to record these Q&As. It was very special to me to be in this place of great holiness to three world religions, Islam, Christianity, and Judaism. And yet I didn't feel, overwhelming presence of God, even though I was lecturing about it. And so for me, God is an intellectual pursuit. It's something that you can never really approach with an understanding that you could say, I believe in God. As Jordan Peterson, who's become a friend, says, who is a man to say he believes in God? Like, does God need Brian Keating's approbation? I think it's an example of hubris that we say, well, I believe in God. Well, good. That doesn't tell me anything about you. What do you do? What is your practice? How does your belief in God alter your behavior or not alter your behavior? That's fine too. And as I talked about with Peter Boghossian, Michael Shermer, these are noted atheists. I love Lawrence Krauss. I love talking to these people. But by the same token, I feel like religious people have an obligation to learn more science. And scientific people shouldn't really comment. Like, Lawrence knows almost nothing about Judaism. And that's because he has a block again. He doesn't want to learn about it. He learned last about Judaism when he was 12 years old, preparing for his bar mitzvah. and he's 20 years older than me. So this is a long time ago, and I feel like they stopped learning at that age. They would never take the disproof of a mathematical or physics proof from a 12-year-old, and yet they will do it from their 12-year-old self to refute any belief in God. And there'll be a couple of questions later on. You'll see more about religion/spirituality. Thanks again. Okay, Awesome Possum asks, are we, parentheses humans, thanks, not possums, a solution to Fermi's paradox? Is DNA engineered by an alien civilization to colonize the galaxy? I know it doesn't answer any deep questions, but it's kind of interesting, specifically given that a lot of controversy exists regarding origins of life on Earth. Well, I think DNA engineering is an interesting concept. You'd have to ask, well, who engineered the DNA, who or what? I've talked to many, many people, from Jamie Green to Carl Zimmer and Eric Kirschenbaum and many other people, and it's just clear we have no real strong notion for the origin of life in the universe. We have certain concepts of how life could have originated elsewhere and come to the Earth, panspermic origins, as Fred Hoyle would call it. But DNA is pretty interesting because it does seem to be a type of code, technology, software code in a sense. That if you say it was engineered, you have to ask, well, what's engineering it? But let's leave that aside. It is kind of like a time capsule. It is the ultimate time capsule, the ultimate storage machine. Doesn't require batteries. There's this Kevin Kelly works on this Long Now Foundation, this 10,000-year clock. That's nothing. I mean, compared to even the DNA that we found from Neanderthals or dinosaur, remnants of these things. So it's just incredible to think how persistent, how self-resilient these DNA structures are, how they self-perpetuate and store, copy, transmit, get modified, but are error correcting. It does almost seem like a magical technological invention. And then so the answer, the solution to Fermi's paradox would be that the aliens, colonized us, so we are them. The answer to Fermi's question is that they're here, they're us, they made us, or perhaps, they're still here. And other people like Paul Davies, who I'm going to be hosting in a few months, are back here at San Diego. Has proposed there might even be a shadow biosphere. There might not even be aliens here using different types of DNA that our assays cannot really interact with, so we are ignorant of their existence. Again, speculation. It is a potential solution. There's a book I've started reading called 75 Solutions to the Fermi's Paradox, and I have to check in there to see if that's one of the potential resolutions of Fermi's Paradox. Okay, Christopher asks on Twitter, is it possible, given the evidence, that humans have been advanced on this planet way longer than we thought? Not really sure. I mean, humans are, if we consider them as Homo sapiens, they certainly haven't been here longer, at least, the evidence in the fossil record, technological record. Remember, you can date things in many, many ways. You don't just need carbon-14. But what we have dated things in Neanderthals prior to that, and Homo habilis, and going back to the 3 or 4 million years ago in Africa. Those are pretty advanced primates, but not of the Homo sapien genus and species. So, is it possible that there's evidence for? Well, the lack of evidence doesn't prove that they weren't here. It's there are very few bones and tools and things found. It doesn't mean that before we found them, we would have thought that man was maybe only 10,000 years old. And that's certainly disproven by the fossil record. So will we find things that indicate that Homo sapiens actually have a longer legacy on Earth? Perhaps. We don't have that now, Christopher. Bentation Funkalogio. If spacetime is curved by even an infinitesimally small amount, might standing gravitational waves exist? Well, okay, so this is borrowing a concept from electromagnetism or even from standing waves and water waves or on ropes. called a standing wave, where you can have a persistent oscillation which has the appearance of what's called a standing wave, a constant pattern, even though, of course, the air molecules are moving inside of an organ pipe where these types of phenomena exist. Or if you have a rope and you wave it up and down at just the right frequency, you're actually sending canceling and interfering constructively and destructively waves in opposite phase velocities. And so that can lead to standing waves in ropes and electromagnetic. That's how your microwave has a certain standing wave pattern. Now, they're not stationary. The electromagnetic fields are oscillating at 10 to the ninth or higher hertz in the case of microwaves in a microwave oven. But so you don't even need a small electromagnetic field. Those could be large electromagnetic fields. Standing gravitational waves, you'd have to find a solution where there's a boundary condition that is stable. So in a microwave oven, the boundaries are the metallic walls of the microwave that pin the electromagnetic field to zero at those spatial extents. Similar, holding a rope or an organ pipe with air density waves standing within it. So you need some stationary pattern. And the problem with gravitational waves is that when you have them generated, they can only be generated from moving sources, sources that have dynamical, what are called quadrupolar moments that vary in time. So it's not probable. Doesn't mean it's not possible. And a lot of the electromagnetic wave behaviors do propagate, no pun intended, to gravitational waves. So it's not, totally crazy idea. Thank you, Bentation. Okay, Faust asked. He doesn't ask. He just says, "Well done, sir. You have a quality show from one humble opinion." Thank you so much. I love to hear those kinds of comments and questions. So I won't say this person's name because he's kind of annoying. He is claiming that he is talking to Einstein while I am a loser with fame. Just to let you know, I do get an awful lot of hateful, weird, strange people on Twitter. I try not to block. I don't think I've ever blocked an actual follower, even though there are many, many people that have tried to bait me and say mean, nasty things about me or my friends. I think blocking should be reserved for the kind of most egregious people. And some of the people have said egregious stuff. It's just not about me. They're just obviously crazy individuals who are chemically imbalanced. I don't know if this person is. It's very strange. He's contacted me many times. And just to let you know, those that aspire to produce things in the public eye will always find people that are trying to take them down, that dislike them, maybe even hate them, even though they've never met me. And it's sad, but I'm trying to do the best I can to communicate the cool stuff that I get paid to do and learn about to you who pay my salary, many of you, at least if you're in the US or California especially as a public university employee. So yeah, it's not all the sunshine and roses, although comments like the next one are fantastic. Here's the next one. Barry Straw says, "Congrats on the milestone. My question to you, how do you like the media side of things? The physical clicking of virtual buttons and media tools, your favorite apps and programs and favorite tools in your line of work, physical and software?" I'm going to answer this a different way. I'm going to tell you the podcast that I listen to on my iPhone, which is somewhere around here. I listen to a lot of weird podcasts that you might not think about, a lot of business podcasts. I like a lot of productivity podcasts and YouTube channels. And some of them influence me and have helped me grow and thought about new ideas and new tools. The tools I do enjoy, kind of the being in front of a microphone. It's taken me a long time to get comfortable doing one of these where I'm just talking to you, which is really just recording, and I'm not physically having a conversation with somebody. It's kind of strange. Asking, it's kind of like communicating with an alien civilization, not calling you guys aliens, but calling you intelligent. The soonest you could get a response is, round trip time is 8 years if it's on Proxima Centauri B. So you have to be comfortable kind of talking into the ether, and this is no different. So I do love tools. I probably have an addiction to my iPhone. I use it many, many hours a day and various apps on it, X, Instagram, YouTube Studio. I love replying to comments there, and you'll find out more comment replies in just a minute. So I do a lot of that. I watch a lot of YouTube. Channels I enjoy that have really benefited me. in part because they're so different from what I do. Podcasts like Tim Ferriss I listen to is very different from what I do. He's taught me a lot about interviewing and peak performers, and I could probably do a much better job than I do. Um, Other podcasts, one's called My First Million with two tech bros. They just kind of have a fun rapport, and they get along great, and I like to listen to them. Totally out of the uh, the realm of what I do. Similarly, I listen to, for the last, probably the longest podcast I've ever listened to is one called Mac Break Weekly with Leo Laporte. That's been going on like the early 2000s. It's on video, comes out every Tuesday. They have a great rapport, no pun intended, with Leo Laporte. Learn about the Mac tricks and tools, and become a Mac addict in a lot of ways. It's just so easy and seamless. Of course, my friend Lex Friedman, Joe Rogan, I listen to them. Jordan Peterson, less so. Jordan he's very much involved with culture wars and politics, and I do listen to Ben Shapiro pretty regularly, pretty much every day. Dennis Prager is another one I listen to. On the right side of the spectrum, on the left side of the spectrum, I listen to Kara Swisher and Scott Galloway, who's the only person really who I've been kind of annoyed with, who didn't come on the podcast, even though he agreed at least to come on with James Altucher, that he'd come on, never responded to any of my emails. So Scott, if you're out there, that's not cool. You had this wonderful, message that went viral when you had a student show up 15 minutes late to your class once, and you just took him down, and you're doing it for his own good. Well, the same thing happens, in the podcasting world. I've had 17 Nobel Prize winners on the show. Not once did they ever fail to write me back, even the ones that didn't come on. So it's just, come on, buddy. Let's get our acts together, especially when it comes to giving back to the University of California, which you've given a lot of money to, but this is the biggest podcast in the history of the University of California, and you're a native son, so respond to an email or two. It would be a classy thing to do. Other than that, tools and tricks. I listen to Sam Harris's Waking Up app. I don't care for him politically. I think he's really gone off the deep end, but I give him my money, and he does great work in meditation space, and I'm not that great at it. But it's something I can, kind of adhere to, and where it's using technology, it's using my phone, I'm listening to something, I'm learning from all these great individuals and speakers that he has on. Ryan Holiday, again, he's a past guest on the show. We don't really agree politically on as much. He's another person who's, kind of gone off on the anti-Trump, kind of Republican side of things. And so I think it's, kind of incumbent upon people to listen to people they don't agree with. And I do that a lot because there's a lot more media out there, to consume than I can actually produce. So thank you for that question, Barry. Okay, Restonian, R. Estonian, who are your role models growing up and in your professional life? That's an awesome question. So even though my father was a professor, he was never really around growing up. So he wasn't a role model to me at all. And so I had to really get those role models from, my mother and my older brother, but also from books and reading. This is pre-internet, pre-Google. And the ones that really spoke loudest to me have been people like Galileo and Isaac Asimov and Carl Sagan. And really proud to say I was able to follow a little bit in their footsteps to whatever extent I've been able to, and that is to write books and communicate with the public like they have done. And I think that's a way to give back. Carl Sagan said, a book is proof that humans can work magic, because you have this long-dead author speaking in your ear, teaching things, and you're participating actively in learning. Well, I'm still alive, thank God, and hopefully will be for a long time. But I'm writing books, but I'm also doing podcasts, so you can actually hear my voice. I don't think he did. There are a lot of videos of him, of Carl, and I'm proud to say I had his daughter Sasha on the podcast, and his widow, Andrewian, on the podcast, and we talked about contact and all these cool things. It was quite a treat to actually write books and kind of have a little bit of their intellectual DNA sprinkled throughout the writing process that, I hope to continue and hopefully inspire other people to do someday. Okay, K or T, ask, what is a practicing agnostic, and do you include the multiverse and Spider-Man? Well, a practicing agnostic is to be, distinguished from a atheist who doesn't go to church or synagogue or mosque, and a practicing agnostic is someone who does go to those things, but doesn't necessarily believe it's knowable whether or not God exists. So that's agnostic. It's not knowable. That's what it means. But if you don't go to church, what really distinguishes you as an agnostic, self-proclaimed agnostic, which is only self-declarable. So, but how would a behaviorist look at you and say that you're behaving? Are you acting like an atheist? Are your actual practices, do you, just for whatever, do you violate the 10 Commandments? That's not the ultimate, arbiter of good or evil or spirituality or atheism. But it is a standard, right? So you may say, well, I don't kill people, I don't steal, I don't bear false witness. But do you, though? And what does it mean to bear false witness? What does it mean to steal? Like, does it really mean that you only don't steal, an iPhone from a store, or, break into to a Nordstrom's and pilfer a sweater? Is that all that stealing entails? Or do you ever steal a joke or steal an idea, not give credit to something that influenced you? That's actually considered a big sin in Judaism. It's considered genevas das. It's stealing thoughts, making somebody think that you are doing something when it was actually either the opposite of your intention or just completely unintentional. A good example I've heard is, say my friend Amanda invites me to her wedding in Australia. I actually don't know if she's married or not. But let's say she does, and I'm like, I'm not able to go, but I don't get back to her. I don't even RSVP. I'm just kind of a jerk. And then I happen to get invited to go down to see, to give a talk, with my friend Luke Barnes or Garrett Lewis or Brian Schmidt. And I'm down there and I'm at their universities and I'm giving a talk. And then Amanda walks by and she's like, oh, Brian, you're just the best. I'm so glad that you're here. You came for my wedding. It's just so wonderful. And if I say, yeah, I wouldn't have missed it for the world. Didn't you get my RSVP? That seems like innocent. You're not really, you don't want to hurt their feeling. No, I'm actually here to talk to somebody else in Australia. Showed up here. Just a coincidence. And, it's hard to say that. But then think someday if my kid's going to have his bar mitzvah. And then I invite her. And then she feels all this pressure because Brian, flew all the way just to see me, just to come to my special day. That's a form of theft. Like you're tricking somebody. You should be honest. It's very, very hard to do. And I'm not saying I'm, innocent all the time with perfectly clean hands. But being a practicing agnostic means that I'm searching for answers. I'm searching to see if God, if there's evidence for God, can I approach God? But I'm doing so within a framework that's guided by the wisdom of thousands of years of tradition. And I'm not advocating Judaism exclusively. I'm saying you should find a faith tradition, maybe the one you were born into, although that could be an accident, according to Richard Dawkins. No one is born Christian, because Christian is a belief-based faith, which is true. But I think he's saying it, to kind of denigrate parents who raise their kids Christian rather than to say intellectually it's a true fact that you can't be born believing something as a 1-day-old child. Nevertheless, I do think it is important to have some form of practice where you do think about and distinguish yourself from a pure atheist if you're going to call yourself an agnostic. Otherwise, it's just purely. It may mean something to you, but it won't mean something to anybody else, and you won't certainly be able to influence people to kind of persuade people, whether religion is their cup of tea or not, that there's any distinction between what you're doing and doing, strictly doing nothing. And again, not with a value judgment, just stating a fact. Most atheists don't do anything, and then most agnostics including the first guest on the podcast, Freeman Tyson. I asked him, do you go to church? No, but you call yourself an agnostic. And, he had to think about it. So go back and listen to or watch that episode to get his reply. I skipped one from Gonzalo Chavez. Can you invite someone from the following UFO offices in South America? Probably not. I don't know what a UFO office is. He says, because of that, you can then stop debating whether UFOs exist. You're able to show your audience imagery and discoveries made by countries. So there's a lot to unpack there. I have enough trouble staying on top of what NASA, the DoD, the Pentagon, the pilots that I interview, the pilots who I've talked to but haven't had on the show yet. There's a lot of information out there. And I don't think it's, fair to say that these are the, kind of standards. The sine qua nons are the DIFAA in Peru or the SEFAA in Chile. I'm not opposed to it, but I'm not going to make a lot of effort to go and talk to these people in a language I don't understand, with various types of data that I don't understand either. That said, I would certainly be interested if people do contact me. And I do get a lot of people reaching out. And I thank you. I just can't host every single person that, has a sighting or eyewitness, to be on the podcast. Okay. Recromorchian Lemniscate. Do you have any comments or thoughts on potential superconductive interactions in space? And he has a paper from the Proceedings of the National Academy of Sciences about superconductivity found in meteorites. And in fact, I believe, I'm clicking on the link now, yes, it was written by two of my colleagues, Mark Tiemens and Ivan Schuller. This is superconductivity found in meteorites. Yes, I did talk to them about that. It's a fascinating discovery. And superconductivity can be found in nature. And in fact, the first elements to be found that were superconducting are just pure elements like lead. So those are certainly found in space. But these are more exotic ones in different phases and environments. And so it's a fascinating discovery made by Ivan Schuller and Mark Tiemens, my two friends and colleagues here at UCSD. Okay, Nico Grunenberg writes, keep up the great content. I hope that the amazing show on Rogan helps you more with followers. Your incentive was not to push back and make arguments commensurate with Rogan's greater than 50% fan base. You did not yield. The clickbait on Kurt's Reddit channel is a bit much. Well, sometimes I do, post on Kurt's channel when there's something relevant. Although I don't have any time to do that lately. But I do thank you, Nico. That means a lot to me. And yes, I didn't, I kind of, mixed feelings. I did write a long blog post, which you can get on briankeating.com under blog, about what is it like to be a guest on Joe Rogan's podcast. It's the most popular podcast, not only currently, but in history. My podcast, the Into the Impossible podcast, rocketed up to number 71 on all podcasts in the world. There's 5,344,000 podcasts. And this one that you're listening to is number 71. For one brief shining moment, and now it's plummeted probably to number 2,700. But it's still in the tops on science and natural science on Apple and Spotify and elsewhere. So I'm really grateful. It's a very enduring, the fan base, so to speak. Number of daily listeners went from almost doubled to nearly 100,000 on the audio alone. And I got, maybe another, 10,000 subscribers on YouTube. So yes, it's incomparable. Joe's great. I did have one friend, I won't say who, is a very popular podcaster. He said, the most important thing is not that you got on Joe Rogan, it's when you get on Joe Rogan a second time. And I'm like, come on, man. Like, you're putting a lot of pressure on somebody. I mean, the number of people, he's only had 2,000 shows. Mine was number 2023, which is kind of cool. It's the only time that'll ever happen. The year of the podcast number is the same. So, what are the odds that's ever going to happen again? I am in contact with Joe. We became, somewhat friendly. He did offer to, he did accept my offer to get together on the eclipse of the sun that'll be visible in Austin next year. So tentatively, we have plans to get together. He did call me a handsome devil. That was pretty nice. But, it's not like we, exchanged numbers. Since that episode, he did mention me by name a couple weeks ago, and a comedian, Mark Rife, I think, Matt Rife, or Ryle. So we made a little clip about that. So obviously made an impression. and hope to be back. I didn't want to just be a pushover and just, kind of a slathering praise on all the people that come on, whether it's about UFOs or the, previous cosmology guests on. I just made the point that unlike Neil deGrasse Tyson and Brian Cox and Brian Greene and Eric Weinstein, and I think I was the first experimental physicist to ever come on the podcast. And as such, I felt it to be my responsibility to bring a whole bunch of demonstrations and experiments. And we did a lot of cool stuff. So if you watch it, it's linked on my website, briankeating.com. You can watch the whole thing or clips of it. We're chopping them up, putting them on my YouTube channel so they get demonetized instantly, but that's fine. We don't do it for the money. We really just want to show the universe, kind of the cool stuff that Joe and I talked about. And yeah, I do hope we get back on at some point. But it was kind of a a real highlight, certainly from this phase of my life where I've switched, from being, purely, I'll say, just a professor, in the work realm, to balancing this, kind of, I won't say side hustle because it's more than a hustle. It's something I really enjoy doing. I lose money on it. It costs me a lot of money to maintain the editors and thumbnail designers and audio producers, and that's a lot of money to do that. But not really doing that for the money. It's a lot of fun to communicate with people and get to talk to great authors. And now I'm at the point where, I have Nobel laureates asking me to come on the podcast. I say no to that. No, I don't. I'm hoping to write a second volume of Into the Impossible, Think Like a Nobel Prize Winner. At some point, I have ideas for another kind of popular science book with some hardcore science like losing the Nobel Prize was. And my day job is still incredibly important to me and meaningful to me, to be a professor, to teach young minds and to get them, to a state where they know more than me and contribute more than I can. It's the ultimate leverage in science, and it's our ultimate obligation as leaders, as mentors, as scientists, professors, and no matter what level we're at. Okay, Bill Anderson, last question from Twitter before we move to YouTube. I'll have to speed this up, or otherwise it'll be my longest episode ever. Bill Anderson asks, what new technology might be on the horizon to help us detect at least the big asteroids that might deal us a death blow? E.g., would lunar-based sensors help with this? That's a very good question. There are a lot of new types of technology. My good friend Phil Lubin at UC Santa Barbara has worked on laser ablation and blasting these things with lasers. I think a lunar-based laser could help because you wouldn't have as much energy wasted going, transmitting through the Earth's atmosphere, and all the challenges with that, like hitting a satellite, hitting a pilot, in a plane, killing birds, and these are real concerns that he has. So certainly putting something on the moon would do that. I think advances in AI is a huge buzzword, but it could be, unless it feels like that's not in its best interest. It wants the asteroid to come here. I think the machine learning, and also in orbital mechanics, that's going to be a huge boost. Calculating trajectories instantaneously and at farther and farther distances for smaller and smaller objects, maybe even pinpointing where these things are going to impact, rather than where they did impact post-impact, like Avi Loeb has discovered with these interstellar meteorites. So I think, detecting them farther out and also, producing the types of technology to deflect them via lasers or even projectiles at a much greater distance, the better, the sooner the better. And, kind of real life don't look up scenario could be avoided. So yes, Bill, that's a great question. All right, let's move on to YouTube. But again, as a reminder, not only do I post these, kind of take questions on YouTube and on Twitter and on Instagram for my guests, I try to promote it a couple days ahead. So-and-so is going to be on the podcast, leave a question for him or her. But I also put up polls and stuff. And one of the polls I had on recently after this question by Bill Anderson that you just read was, what do you think is the biggest threat to humanity? And it was climate change, nuclear war, asteroid impact, or something else. And, almost everybody put asteroids and a nuclear war above climate change. as as an extinction-inducing event, which I tend to agree with. But it was great to see some of the other selections that people had on there, like artificial intelligence and whatnot. So yeah, so do comment on polls and stuff at these various places. It helps me get to know you and what you're interested in even more. Okay, now let's switch to YouTube, where I took questions as well. All right, from YouTube, Wolfenstein or Wolfstein. Congratulations, Dr. Keating, 150,000 subs. My question, do you think the physics community will ever realize that physics, constants, space-time geometry, wave functions must be caused to exist by some kind of mechanism? And should we search for that mechanism? Well, the answers are no and yes. Should we search for the mechanism? Yes, we should. Is it a necessary categorical that these things must have been caused to exist? A wave function. Let's just take wave functions or waves in general, for that matter. Electromagnetic waves are complex quantities. These are fields, electromagnetic fields, discovered by Michael Faraday or coined by Michael Faraday. Was the proprietor of the Royal Institution where I spoke, and you can watch my talk on the beginnings and end of the universe on their channel. So do they have to be caused? Well, if you're talking about a physical mechanism, sure. Electromagnetic waves, complex, they have an imaginary and a real part, can observe only the modulus squared of such entities. Same for quantum mechanical wave functions. Although for some reason people think of the wave function psi, the solution to the Schrodinger equation, as somehow more mysterious and woo-woo than the wave function of electromagnetism, but they're both these complex quantities. They both describe things that can't directly be observed, but the derivatives of them, in the case of electromagnetics, or the squares of them in the case of quantum mechanics, can be observed. So cause is kind of a loose term, unless you mean some kind of first cause, like a god, or an Aristotelian notion of a god, or so forth. So we should search for the origin and how they came to be in existence, the constants of nature, for example. But to say that they had a value and selected for a purpose, that implies a teleology that I think is beyond what physics is capable of saying. Happy Days 66666 says, congrats on 150K, well deserved, thank you, sir, or madam. Question, what do you think about the World Economic Forum and its members dictating global practices, policies for medicine and science? Well, I asked this of Neil Ferguson when he was on late 2022, and he told me, in his opinion, we shouldn't worry about them because they're this international organization, this World Forum. Really, people get together for this binge of kind of, it seems to be prostitutes and skiing, and might be fun for some people. But he said they don't have a navy, they don't have an air force, they don't have any military. Yes, it's true that they'll have Vladimir Zelensky will speak there. You'll have Anthony Bourla talking about vaccines. But would they not be advocating for vaccines and and for aid to Ukraine without the World Economic Forum? It sounds like there's many places. So he thinks of it as kind of a bugaboo, a toothless dragon or tiger. He's not too worried about it. I try to stay out of it. Yeah, they're obviously, kind of seems to be a menacing, mendacious group of individuals. I think I've had on only one guest or speaker there. That was Lawrence Krauss. I think he used to go there. He's not going there anytime soon, although he will be speaking with me here in San Diego on, I believe it's October 17th at the San Diego Air and Space Museum. So come see Lawrence and Brian in conversation. But to my knowledge, I haven't had any other WEF members on. But, Klaus, call me, okay? Okay, Reza Ahand says, congrats for 150K subs. Awesome, thank you so much. And my question is, how robust and reliable evidence for the Big Bang? Do you think there's a tiny chance cosmology one day will be taught without the Big Bang? And if so, what are the implications for physics and our understanding of reality? Well, something like the Big Bang happened. The question is the Big Bang the beginning of time? Was it really the beginning of the universe, or merely our observable universe? So Clearly, the elements were synthesized. The light elements on the upper left of the periodic table were synthesized in a very hot, dense phase. There's leftover heat in the form of the CMB. There are other indicators of this extremely early phase of the universe that was very radically different from our universe today, where the universe was a fusion reactor for many, thousands of years, and then it stopped. That's not going away. So that's part of the Big Bang. Was there a possibility that the universe began maybe earlier than the Big Bang, 13.8 billion years ago with another universe? Yes. Are there other Big Bangs going on simultaneously? Yes, that's a possibility. So that would affect our understanding of reality, as Reza is asking. But the fundamental, kind of notion won't be overturned that the universe had a hot, dense phase that incubated the first nuclear atoms in the periodic table. That's not going away any more so than, Newton's gravity of, projectile motion went away when Einstein came along and gave a deeper understanding of gravity as the behavior of certain metrics and geometry in space-time as a whole. So that didn't go away, it merely got subsumed. So too, if there is a bouncing cosmological model, then or a multiverse, that doesn't mean that the Big Bang phase of nucleosynthesis and the production of the CMB will ever be overturned, in my opinion. And that's only a recent, 50, 60-year-old discovery. Dan K says, congrats, love your channel and the Rogan episode. Thank you so much. Joe Rogan was a blast. He's asking about the famous double slit experiment. Why does the electron not smash against the wall between the slots? And how are you sure that the electron bounces in the room until it lands on the detector wall? So double slit, with electrons is a very mysterious experiment, the consequences of which in some people's minds lead to things like the multiverse with multiple convergent paths being instantiated or realized in different branches of the universal, wave function. There's no evidence for that. I did talk the very first podcast episode that I ever did for real. It was back in 2019 with Sean Carroll about his book, Something Deeply Hidden. Horrible audio, grainy video. Recorded in person though, and that was cool. At Loyola Marymount University in LA. But we talked a lot about that, and he admitted that it's his favorite of all quantum mechanical interpretations, as it's called, but nevertheless, there's no necessary evidence for it. In the double slit experiment, yes, the electrons take each path, and then we're seeing their interference between them as they behave like matter waves, and that was known about since the de Broglie wave particle duality hypothesis of the early 1920s. So I think it's quite astounding. It is amazing that light and particles, matter, behave the same way, but if you interpret particles as waves, very short wavelengths and localized packets of information, then you can interpret them as subject to interference phenomena the same way that water waves or electromagnetic or sound waves behave. Okay, Busy Billy B33 says, congrats. My question is, what are the implications to our understanding of the cosmos of primordial gravitational waves are 100% confirmed to exist? Well, that's the main focus of my research. We're trying to understand if inflation took place or not, or if some alternative to inflation took place. So the problem is we can't prove any of these models. We can only refute them. And so you ask later, does it have any impact on multiverse or cyclic models? Absolutely. In fact, that's the predominant impact of the discovery. If we do discover gravitational waves, it absolutely falsifies the cyclical models, and it gives circumstantial evidence for the multiverse because they are a consequence of the inflationary model only, and within almost every inflation model lies the multiverse. And that we talked about with Will Kinney, who's coming back on the show soon, talk about his book, An Infinity of Worlds. The Memes of Destruction, long time listener, and many time questioner even as well. Simon's Observatory aside, what future experiments or tools have you most excited? I am very excited about technology in many forms, including artificial intelligence, and also discoveries that will be made with telescopes that are complementary and different from the Simon's Observatory. And those include the Vera Rubin Observatory, the Raman Space Telescope. We're still getting really cool images from the Webb Telescope. I didn't think that the said this when I was on Lex Friedman's podcast. I didn't think the Webb Telescope images would have the impact that they have had, merely because the Hubble images were so spectacular. There's really nothing ever like them. And the Webb images are better than the Hubble images, but they're not like orders of magnitude better. In fact, some of the claimed discoveries that seem to refute the Big Bang and so forth by people we've talked about before, those were claimed based on the appearance of galaxies in the Hubble Deep Field 30 years earlier. We are seeing things in the infrared that we didn't see with Hubble, so that is of an order of magnitude, so to speak, better. But it is overall, the images that we're seeing are they're spectacular and they're quite fascinating. But maybe I can admit that I was probably wrong. I didn't feel like they would have as big an impact as the Hubble images have had. So I was wrong about that. But the Nancy Grace Roman telescope will be phenomenal. The Vera Rubin telescope will be stupendous, imaging the whole sky with I think 6-meter telescope every single night, looking for transients, looking for Planet 9, looking for baryon acoustic oscillations. These are going to be phenomenal instruments, and some of which will be complementary to what we're doing with the Simons Observatory. We don't only look for gravitational waves. That's just one of about 9 different science cases. And speaking of 9, one of the things we're going to be looking for with the large aperture 6-meter diameter telescope in the Simons Observatory is the thermal emission from a hypothesized Planet 9. And I'll have a video soon about many times that we've thought we've discovered Planet 9, including by past guest Konstantin Batygin and others, and how those did not pan out. So I'm actually going to do that as a YouTube short. I'm playing around with different formats. ULV02 asks, in a global military conflict, are scientists from opposing nations allowed to still collaborate on projects, or is that considered treasonous? In essence, within that scenario, does scientific progress slow down, stop, or is not affected at all? I think it does go from, it depends on if you're dealing with 2 free societies, democratic societies, although I don't believe that 2 truly democratic free societies have ever gone to war in the modern age. You've had authoritarian, you've had communist dictatorships, you've had Cold Wars, but even during the Cold War in the 1960s to 80s, there was still interchange of information, scientific information. Stephen Hawking going to Moscow in the 70s and 80s, and scientists from the West like Zeldovich, or from the East coming to the West like Zeldovich and my advisor Alex Polnareff. But really, it didn't compare to the fall of the Iron Curtain, when that really, allowed a complete exchange of information. It was very difficult during the Cold War. I think during a hot war, I can't imagine scientists at the Moscow State University are really collaborating with Kiev Institute of Technology right now. I think that's just impractical. But we do collaborate with people that we have effectively Cold Wars with, like China, Vietnam, and North Korea, not at all, but places even like Iran, we have students that come and study, but it's a one-way street. People want to come to free societies, and for America, for all its flaws, is still the freest, best country in the world. So a lot more people come here, and so if anything, it's a challenge to come here because we're so free and because we have so few visas to let the most brilliant scientists come to. But I've had students from Thailand and China and Uganda and Saudi Arabia. It's incredible how very different societies have ability to unite over shared passions for science. With technology, it's a little trickier because that could be used to do for military purposes. But for cosmology, theoretical, experimental, there is exchange, but it is limited the hotter the temperature of the war. Okay, Willis Fouts asks, congratulations, Doc, you do well with this media. Thank you. It's been a real fun ride for me, totally different than anything I ever did before 2020. And it was probably the only really good thing to come out of the pandemic, is that I was able to get access to guests that didn't even know who I was. And that kind of nucleated the podcast, and it's grown, from one subscriber back then to 162,000 as of yesterday. Okay, he asked a very long question, and so I'll see if I can summarize this. It's about the process of evaporating black holes by way of Hawking radiation. It's a little echoey down here. So the understanding of Hawking radiation, which is really built upon the work of Jacob Bekenstein, was that black holes could experience radiative processes. They could have net radiation coming out of them due to what is now called Hawking radiation, which is incredibly tenuous, very, very cold heat that would be emitted, and it would be the consequence of what are called virtual photons, where you have particle, antiparticle, maybe colliding near the black hole's event horizon, or maybe just nucleating out of the vacuum is a possibility for photons and their antiparticles, which are also photons, to be present. And typically, those photons would annihilate each other. Or cancel out, interfere destructively. But if one goes inside the event horizon, it can never escape to combine again with the other one. So these then will be left with an unpaired glove, so to speak. And that unpaired photon then goes out can go out to infinity and radiate away energy. And it was discovered that the amount of radiation is proportional to the temperature is proportional to the surface area of the black hole, which is related to what's called its entropy. And that brings in all sorts of other things like the holographic principle, that normally the amount of stuff inside of a volume determines its mass A, or its information storage content, which is related to its entropy via what's called von Neumann entropy. But in the case of black holes, the surface area contains all this information. So it's kind of like the boundary is a simulacrum of the bulk. And so anyway, yes, this process is described by Bekenstein, and then built the entropy formula was really discovered by Bekenstein, and then Hawking extended it to the quantum mechanical pair production annihilation of virtual and real photons, where a pair would be unpaired, and one of the partners could escape to infinity. Constant Pegasus, or const Pegasus. How long do you think it will take to use neutrinos to see past the cosmic microwave background? Very cool question. The cosmic neutrino background, there's actually two of them. There's a neutrino background in the form of the elementary particles that were pair produced and annihilated during the electroweak phase transition and the formation of the elements in the first nuclei at the 10 to the minus 15 second time scale after the Big Bang, where in that same nomenclature the inflationary epoch takes place at 10 to minus 36 seconds. So it's to see past the cosmic microwave background. It would be possible using gravitational waves, as we're trying to do, because that's past in the sense of earlier epochs. Neutrinos decouple at an earlier time as well from the bulk, and therefore they would have a colder blackbody temperature. They would trace an era. Instead of tracing the error of 2.7 Kelvin, they trace an error of 1.9 Kelvin, which doesn't sound like that much, but it's actually, could be equivalent to many thousands or hundreds of thousands of years. Neutrino decoupling. There's also a relic background of neutrinos from all the supernova events and all the nuclear astrophysics events in the universe's cosmic history and our cosmic volume. And that could actually be the limit that prevents us from going deeper when we look for dark matter. Because as I've said many times, and it's one of my more controversial opinions, we know dark matter particles exist. They're called neutrinos. They don't interact with light. They're weakly interacting. They have mass. We know they have mass. We don't know what their mass is exactly, but that's part of the goal of the Simons Observatory, is to measure, not just constrain their mass. So these cosmic background of neutrinos, either the decoupling era or the neutrinos that emit from all the astrophysical processes and nuclear processes, including supernova events, that could provide a floor below which is impossible to keep plumbing the depths to understand what dark matter exists and that dark matter's properties. Okay, next question. Rob Dealsman says, congrats, well deserved. Thank you so much. Thanks for being a member of the multiverse. What do you suspect is our era's phlogiston? That's a great question. So phlogiston was this hypothesized substance that allowed for combustion before Priestley and others described oxygen as a necessary ingredient. So today's phlogiston, I think, at least in the physical sciences, we may find that the detour that we spent, the adventures that we spent, trying to look for supersymmetry and string theory and building ever larger accelerators was a waste. What we really should have done is built more cosmological telescopes. And I'm not just tooting my own horn. I say this about every type of cosmological experiment, including those that are looking for signals very different from what I can detect with my colleagues in the Simons Observatory. And this ties into the next question by Kaduramu 43. If you controlled the budget for science in the USA, what experiment would you want to do and why that above all the other options? I do feel blessed to be able to participate in this experiment called the Simons Observatory because it has this enormous budget, $100 million budget. Plus, and we're expanding it, it's going to be about $200 million by the time it's done. There's another experiment called the CMB Stage 4 experiment, horrible name, cool experiment, which would be like 2 or 3 of these Simons observatories have a budget closer to $1 billion. And that really would be the definitive experiment. It would be able to do, basically ultimate limit on the gravitational waves that could ever be measured, with moderate technology. It would have, tremendous survey of the sky for things like Planet 9 and asteroids and deadly, comets and so forth. Because everything that exists in the solar system gives off heat, and our instrument is the best for detecting heat. Maybe make bigger telescope, larger aperture than our large aperture telescope, twice as big maybe, higher resolution, and just cover the whole sky, make tens of them because you're giving me the whole budget, which is, not that much. And then try to couple that with advances in theoretical understanding and data mining, data analysis, to look for things like, the masses of the elementary particles, the neutrinos that we've never measured, looking for things like cosmic polarization rotation and Lorentz invariance violation, all these incredible cool things, which comes into the next question from someone other than you, 7732. I hope that more subs will come. Thank you so much. Whatever is the point to Lorentz violation in the standard model? That's a great question. We're looking for a Lorentz violation using cosmological photons that travel across the universe, in that they would have potential for preferential rotation as their polarization orientation gets modulated as they propagate through the universe. And the question is, kind of how can we what would we say about that? What kind of evidence would we have is someone other than you's question. Well, we have circumstantial evidence. We know that the electroweak interaction is parity violating, and a parity violation on the scale of the whole cosmos that implies a rotation of polarization would violate Lorentz symmetry under rotations because it's singling out a particular rotation as the photons travel to the Earth. So that would mean throughout the whole cosmos, you could tell everybody, well, set your watch counterclockwise means the direction that photon polarizations are rotating. That would violate Lorentz invariance. So that would be incredibly cool. We don't have evidence right now, other than circumstantially, that the weak interaction does violate it, and electromagnetism and the weak force are unified in the electroweak force. So we know they're unified, so at some temperature, some energy scale, they must be violated, both electricity and magnetism as well, and maybe even gravity. It might be that gravitational waves have a handedness variation as well. That's an awesome question, something that could come not only from Brian Keating's dream experiment when I controlled the US science budget or the world science budget, get together the World Economic Forum, me and Klaus, and put all the world's resources into cosmological experiments. Stay tuned for that. John Ahern asks a very pressing question. If tin whistles are made of tin, what do they make foghorns out of? John, that question blows. Okay, made of star stuff. Congratulations, next stop 500K. Well, technically the next stop will be 200K when we do the next one of these. I anticipate that'll come in less than a year, and I can't wait for that to happen. Again, it's just a number. It just means somebody pushed a button with the subscribe on it, but it really does influence what kind of guests I can get. I once tried to get Ray Dalio, and his booking agent was like, you seem like a smart guy, I like your stuff. And this is 3 years ago. I had 2,000 subscribers. But they were like, it's just not worth his time. And I get that. I get asked to be on a lot of podcasts as well. And if you want me to on your podcast, I usually, if you have a small following, I'll say, sure, but I want you to do what people told me, which is, when you get above a certain threshold, sometimes it's 10,000 subscribers, then I'll come on and I want you to do that because I'm trying to make it possible for you to grow your channel, your influence, so that you can make either a living or a side hustle from YouTube or whatever you want to do. As I've been blessed to have these great conversations, not to make money necessarily, but to get access to the world's most brilliant minds, particularly authors and scientists, and really promote the people that would otherwise no one would ever know about. Having a conversation with Ina Vishik, who's a condensed matter experimentalist. Like, who the hell knows who that is? She's a good friend of mine, and she's a great guest. And we talked about high temperature superconductivity. Jorge Hirsch, same thing. No one's ever going to talk to. I'm going to seek them out, but I'm trying to bring them to light to inspire some young Ina Vishik or Jorge, some really cool scientists in the waiting, because I think that'll be one of the great contributions that I can make as an educator, is to broaden the scope of people. And part of that is based on how many subscribers you have. It's the most public metric. I mean, imagine you were building a company and every single product that you sold had how much profit you make, or how many people, bought this thing yesterday, and only the largest companies publish such information because they sell so many iPhones. It's not going to be embarrassing to them. But on YouTube, I'll put out a video and 2,000 people. I did a great conversation with Ashley Vance, who's an incredible writer. It was seen by a couple thousand people, but not like, if I do something about aliens, that's going to be, 100,000. And yet I love the conversation because Ashley's a phenomenal intellect. And we build relationships and we get to know each other, and hopefully we'll meet in person, and I'll be able to promote his stuff in the future, regardless of how many views it gets. Okay, speed things up. Radio 2712 says most podcasters are talking about AI, but nobody is talking about nanotech and its implications. So is it possible for you to host a podcast on nanotechnology and its future? That's a great suggestion. I will take it into mind. And actually, I am having on a great author by the name of Chris Miller, who wrote the book Chip War, which is about nanotechnology and fabrication, particularly of these microchips that we rely on both for peaceful and military purposes. And his book is obviously about the struggles between China and Taiwan, America. But actually, when we get advanced AI, we can't really do that without advanced nanotechnology and pushing the limits of technology. And question is, as Feynman said, there's plenty of room at the bottom, but how do we access it? Quantum computers, not necessarily nanotechnological in scale, but the combination of these and the current processes to make GPUs, NVIDIA, and so forth, does rely on smaller and smaller features, which requires more and more nanoscale technology. So yes, that's a great suggestion. Adam Pomeroy, 9463, says, would you get a hold of Dr. Kevin Knuth, professor of physics of Albany, New York, have him come on and talk about the UFO subject? He could even present his slide. That'd be a fascinating conversation. I'm on an email chain with him. I haven't really reached out to him. I've seen some of his work, and I'm going to reserve judgment. But a lot of it is kind of presenting analyses of the physical properties, kind of what we call kinematic analysis. How fast would this object be moving if it started at the 60,000 feet and descended to the sea surface level as a Tic Tac does in 2 seconds, and what kind of material strength would that do, and what would that do to a pilot, and so on. Those are interesting, but those, as I said, those are kind of mechanical analysis. At least what I've seen, and I'm sure he's done much more. And there's only so much time I have. I would like to, investigate more, but I'm certainly open to it. And I have had the thought to contact Professor Knuth. Okay, last one for now is by Ronald Kemp, 3952. Explain how the Hubble constant was determined to be a constant. Then I'll subscribe to my channel, your channel. Oh man, wow, I have to get this sub. If I don't get this sub, I'm going to not get to 163,242. I'll be stuck at 41 for it. Anyway, so we measure the Hubble constant to be a constant, but it's a variable constant in that it will change tomorrow from what it is today. So the Hubble constant is the current time value of the Hubble parameter, where the Hubble parameter is the time derivative of what's called the scale factor divided by the scale factor. So the scale factor symbol is A of t, and the time derivative is A dot of t, and the Hubble constant is A dot of t over A, and that is and that number is defined to be when it's evaluated at today's t, time equals today, as the Hubble constant. So that's how we get it. It's not constant because there is a force in the universe called dark energy, which may be a cosmological constant, which is causing the Hubble constant to get larger and larger with time. And yet we can calculate that and predict what it will be based on the simple behavior of the cosmic evolution equations, the so-called Friedmann equations. So given the dark energy, which is an observable that we have to measure, given the matter content, which we have to measure, and given the radiation content, including neutrinos, we can calculate exactly what the Hubble constant should be. The problem is when we measure it today with parameters derived from the cosmic microwave background, it doesn't agree with measurements done by much, much later time supernova measurements. And that's led to the Hubble tension, where there are two measurements that disagree at the 10% level. One is around 69 and one is about 72 and 73. And their individual uncertainties are at the 1% level. So you have you have a time rate of change that's differing at the 9% level that's excluded by each individual uncertainty by the factor of 5 standard deviations. So it's quite bizarre. And so, yeah, we're learning about that more and more every day, and experiments like the Simons Observatory and the work that past guest Adam Rees and his team are doing will help us understand stuff even more. E-design time. Looks like someone I know, but maybe it's not. Do I like gefilte fish? No, I don't like gefilte fish. I don't care for any kind of fish, to be honest with you. I'm trying to save the oceans and the supply of fish stocks by not eating any fish whatsoever, especially gefilte fish, which means filled fish. What could be more appetizing than fish gelatinously filled with gelatin and some kind of wheat-based product? Okay. Nicholas Brunning says, congrats. When do you think you realize you're wrong regarding the notion of highly intelligent non-human entity or entities present on this planet or proximate? Well, I'd have to see evidence for that, Nicholas. Perhaps you or someone else will find it, but for now, we believe that there is intelligent life on Earth in many different forms, but not beyond the Earth as far as we can tell. Okay, and finishing up the last few questions in this spectacular, thrilling 150K Q&A. And let's see if I can find some really fresh, hot, juicy, swollen, delicious, like nectarines. Here we go. Last couple of questions. Scott Gallery, what are some of the areas of your career where engineering overlaps with a more pure sense of physics and astronomy? I'm an aspiring civil engineer, but I'm always looking for ways to gravitate towards the thing I love more than engineering. Well, I guess that's astronomy. Well, there's a tremendous amount in experimental astrophysics where we build detectors and sensors and cryostats and building really cool, literal, figuratively cool instrumentation that we take to the most interesting places on and above the Earth. So if you're interested, there's almost nothing better to meld an interest in cosmology with engineering practices. And we do have civil engineers that we've employed as contractors at the Simons Observatory site to make sure the platforms have a stable source of concrete pads and compacted earthworks and diesel fuel pipes and overspill protection, all sorts of cool things. So we have actual civil engineers that worked on the project, at least when we were getting it started. So there's a whole range of things in astronomy and in cosmology, from even biophysics, understanding molecules in space, all the way up to discovering the origin of the universe potentially and how that unfolded. So cosmology contains all of these things, multiple multitudes. Okay, last question, maybe. Cassie White, love to hear more about your time at Brown University. My understanding is that an institution vectoring primarily towards medical science, not necessarily, she could be wrong, she says, but having lived in and around beautiful Providence campus and enjoying the fortunate and presumably wealthy student body attending Ivy League University, I'm curious about your experience there. I loved it. I wasn't wealthy. I'm not, typical. I was a graduate student, not an undergraduate. There's a lot of, undergraduates. A lot of them are wealthy. A lot of them are not. It's almost impossible to get into as an undergrad. And they let me in as a graduate student, from Case Western, where I was an undergrad, which is certainly not a place of privilege. And I had to work really hard there, and I held my own. I was one of the better students, the experimental students, and most of the classes are very highly theoretical. There's only one lab class in my time. So there are privileged people there. Grad school is very different, and from the undergraduate population, but it is a beautiful campus. I was honored to speak there as distinguished graduate alumni in 2022. Gave a talk. It's on my website and on their website somewhere. How to think like Galileo to be relevant for half a millennium. I hope you'll check that out. Okay, there's one question I can't resist. Dan K, a person from the past you would like to invite on your podcast. I have to say, it would be my father, my late father, who passed away 17 years ago. And we, had a very, kind of difficult relationship, on and off. But I think later in his life, he came to appreciate that I was involved in science as he was in math. And we could have, done work together. But I think, I tried to do for many years a Father's Day episode where I had on Peter Timby, who was my graduate school advisor, kind of like a father to me. I had on Jim Simons, who's acted like a father figure, at least, kind of mentor to me for many years. And so, yeah, I'd love to have my father on, but, it's not possible. Also, you miss the voice of people. You don't really. I have a lot of images, pictures of him, but I don't have any, voice recordings. He died in 2006, a year before iPhones even existed. So we just don't have any recordings of his voice, and so it would be really cool to preserve that for posterity. I did that with my mother. I did a podcast with her. But it's private. I'm not going to share that. It's kind of like for her 80th birthday, for the family and for posterity. So it was a treat to have her on, and I do hope that I won't miss those opportunities to connect with people while they're still alive, and I could have an in-depth conversation. But I really appreciate that question. Makes me think of my father, and mostly remember the good stuff. And hope I can be a good father for my kids. And someday they want to have a podcast and they want to have subscribers. And one of my sons thinks that when he hits the like button, as I urge you all to do, that he's subscribing to my podcast. So he's like, I subscribed to you a lot of times today, Dad. It's very cute. But I appreciate all of you who subscribe to this channel. I appreciate you tremendously. It gives me kind of a platform. It gives me the gravitas to get great guests on. Still, a lot of guests will say no. Still not big enough. And I do feel like we're undersubscribed given how many cool and interesting conversations we've had and how many more in the works. Pulitzer Prize winners, 16 Nobel Prize winners, 4 astronauts, multiple billionaires, thought leaders, politicians, mostly interested in connecting minds and growing the scientific literacy and uncovering our place in the universe. We only get this brief amount of time to appreciate, and I hope that you appreciate the podcast and the kind of value that I'm giving back, and I hope you'll continue to give great recommendations and to share the podcast with your friends. If you're listening on audio, I'd love to get ratings and reviews, because that's another way, a public metric where publishers will see it and they'll agree to let Malcolm Gladwell or whoever Mr. Popularity, Miss Popularity is to come on the podcast. But I also love having unknowns and making them have a platform of their own. Looking forward to many more adventures together. Can't believe when I first did a New Year's episode or maybe a 100,000 subscriber pre-episode. I was like, oh, who do you want to talk to? And I was like, I'd love to talk to Joe Rogan because I'd love to talk to him about cosmology and teach him what experimental astronomy is all about. And I can't believe in 2 or 3 months since we've grown 50,000 subscribers that I actually did that, and many more cool conversations to come. Stay tuned, share the channel, like and comment and do all those cool things because it really helps the mission. And I appreciate you all so much. So, as they say, to infinity, subscribers and beyond, and I'll see you in the next episode.